Hello ladies and gentlemen, my name is Decryption and I hope you are well. So the world in my game is coming around nicely and we've got a couple of quests now, but it's very empty at the moment. There's nobody walking around, and even when we did have people walking around with the bandit quest where we kill people up here, they just stood still. So I figured now was a perfect time to start looking at adding some really basic AI. Now there's thousands of packages out there to handle AI control and make them do things, but I'm going to go almost back to the beginning and we're going to do it using Unreal's built-in tools, but we're not going to use the behavior tree this time. I've used the behavior tree for years. It works, it's okay for some things, but when you're doing state-based logic, you really can't beat a state tree. So in today's tutorial, we're going to implement a really basic Unreal state tree just to have a random person walk around, and if you attack them, we're going to make them run away. So something really basic, but a nice little addition to the game that we can add in, and it'll be a great time to start getting into state trees. So let's get started. So the first thing we want to do when we get into state trees is we need to enable the plugin, and it's a built-in one with Unreal, so it's fine. I'm going to go to Edit, Plugins, and I'm going to go State Tree. It's a built-in plugin to Unreal, so you don't need to go and download anything. You're going to need both enabled, and then we'll just hit Restart now. And once it's restarted, we can jump straight in creating the state tree. So we're going to come to our content drawer, and I'm going to go into my content folder, and I'm going to right-click, and I'll create a new folder, and I'll just call it AI. And inside here, I will right-click, I will do Artificial Intelligence and State Tree. I'm going to make sure I choose State Tree Component Schema. You can also just click this one up here. And I'm going to call it ST for State Tree, and I will just call this Random Roam, because that's all they're going to do. We're literally just going to make them randomly roam around the city, the village, not really doing much for now. And in the future, we can improve upon it and give them smart objects where they can go up and sit on a bench and stuff like that. Really sell the illusion that this NPC is actually doing something. I'm going to come and open this up. So if you've never seen state trees before, it might look a little daunting at first, but they are actually really easy once you get into it. We've really got it broken down to 3 places. Over on the left side, you have where all your variables go. This is where you add all of your parameters that you want to use inside the state tree, all of your evaluators, which is where you go off and grab other variables for checking data, such as is the player currently alive, or what is the current NPC's current speed, something like that. And then global tasks, which we're not going to touch, but that's a task that you want to be continuously checking. It could be, is the NPC dead, something like that. In the middle, you have your state tree. This is where we're going to build all the different folders and the logic to actually drive our AI. And then if I click on a node, at the side you have your typical details panel. You can set the details for the particular node you've clicked on and add conditions and other bits like that. So let's start with something really basic and make the NPC move around. So what do we need? We need a way to tell our state tree, tell this NPC to move somewhere. So the first thing we're going to do is we're going to populate the context. So the context, if we hover over it, so it's the one who's going to be using this state tree. You could just keep it as an actor and it will pass all the variables to the actor. But if we put any variables on our specific character, such as movement or something like that, if we tell the state tree specifically what type it is, it can better use it and you don't need to cast to it. So in my case, I have my NPCs here. So if I click on this guy here, we have a NPC shopkeeper and it's a type of ALS NPC in my case. So you will probably have an NPC of your own. So I'm going to come in and I'm going to open up the schema here and you'll see we've got a context actor class. So I'm going to come and set mine to my ALS NPC like so. And the only difference that has done now is it means every time we want to use the context actor to do anything, such as get your current position, get if you're alive, anything like that, we don't need to cast to it because it's already got the correct height. So let's start with something really basic. Let's make the AI just walk around somewhere random. So how do we do that? We need to add states in here which contain tasks which go off and action things. So we want to create a new task. At first, we're going to create a new state. So I'm going to click add state at the top and we need to name it. So I'm going to call it walk to random location, just like that. So you'll see we've got a warning symbol here right now. And what this is basically saying is each state here needs a transition of where to go once it's completed itself. So in this case, the route has an automatic transition just to go to the next node, so here. Whereas this one here hasn't got anything else. It doesn't know where to go. So I'm just going to come and click transitions here, add a plus, and it will automatically add one on state completed, go to state route. So when this state has been marked as completed, it will simply go back up to the root state there. And we can make it go to any state we want. But at the moment, we only have a couple of states, you see? We only have route and walk to random location. Now, completed is different to succeeded. Completed simply means it's gotten to the end. It doesn't care if it's failed failed, it doesn't care if succeeded, anything. On state succeeded means they have achieved the task successfully. So for example, if you tell the AI to go to a destination, but that destination's blocked and they can't get there, you may fail it, in which case the on state failed would trigger. If they do arrive at the destination, you may call succeeded. However, you may not care about any of those, so you can simply just call completed. So in my case, I don't care if they can get to the random location or not, just complete it as soon as they've got to as close they can. It'll go back to root, which will come back down and go to a random location again. Perfect. So now you'll see if we come and hit compile, all the errors will disappear, but at the moment it won't do anything. So we need to give this state, the walk to random location, a job to do, a task. So let's go and create our own task. So if I come into my AI folder and create a new folder inside of it called tasks, and I'm going to open this up. Inside here, I'm going to right click blueprints, and I'm going to search for state tree task. And you'll see you've got a couple. You've got the state tree node blueprint base and the state tree task. So I'm going to click task and click select. And I'm going to call this STT for state tree task, and I will call it move to random location. I'm going to open this up. Because we could create a move to location, but then we'd have to create another one to get the actual location they want to go to. So in this demo, I'm just going to put them together and say randomly walk around the world. So you'll come in and you'll have nothing there, no events, but what you do is you hover over the functions here and you'll see 4 to override. Each of these is what you can plug into to tell this task what to do and when to run. So enter state is as soon as this task is called and said run this state. That's where we can put our code, and that's the one where we will be putting our code. Exit state is when all your tasks have been completed or the conditions have been met. So your state tree tries to move on to another state. State completed is when this state tree has marked itself as completed just before it's about to exit, just in case you want to do something there. And tick is for every single time the state tree ticks. Now, one thing to mention, a state tree, just like a behavior tree, will ping itself constantly. It's almost like it's running on event tick, but it's efficient, and Unreal made it. So if you have walked to random location and before they even get there, you mark it as complete immediately, this state tree will just keep going, generate new location, generate new location, generate new location, and it'll take forever and they'll never really get there. That's why you have already tasks built in to do waiting and stuff. So you can tell the state tree to come down, wait at a point, carry on. So it's something you may run into later as the state tree advances, where you're running some logic and you'll notice the logic is running over and over and over and over and over again, and it's not really waiting for itself, and it's because the state tree is pinging itself on tick. So you need to tell it to do it properly. So you need to make sure you balance it properly. So I'm going to come back to our state tree task here, and I'm going to override the function enter state. So what do we want to do when we first come into this state to run this task? So I want to get my character and I want to tell him to move somewhere. So we need to create a variable to pass in the character to this state, to this task, because this task is going to be generic. It can be put on any state tree, whether you're a bird, a fox, or a refrigerator that can't move. This task can be put anywhere, so we need to tell it who it's working on. So I'm going to come to the variables here and I'm going to just put my NPC in, just like we did other context. So I'm going to call it character, and I'm going to set the type to my ALS NPC, and then I'm going to tick the eyeball and click compile. Now, the unique thing about state trees is you can actually tell the state tree which variables are accepting data into the task and which tasks are pushing data out of the task. So you can balance it. The output variables are used quite often on evaluators, which we'll get into later. But in this case, when we call our task, we want to give it the NPC that will be running it. So I'm going to come to this character and I'm going to set the category to input with a capital I, and you'll see it's gone in. We click compile and save. This is now set up so when we call this task, it will ask us to give it a character. So now that we've got a character, what do we want to do with it? So I'm going to drag it in and I'm going to drag off and do get AI controller, and this is going to get the built-in AI controller that Unreal's already set up, and I'm going to drag this off and I'm going to do move to location or actor, and I'm going to plug this in up here. You see we've got a bunch of different things we can fill in. So I want to pick a random goal, so I'm going to right click and do get random reachable point in radius. So this is one built into Unreal, and all it's going to do is look at our Navmesh, pick a random point on it and say go there. So the origin is where we want to look from, so it's going to basically do a big sphere around us and pick a random point within that sphere. So the origin is going to be my character. I'm going to add my character in, I'm going to drag off and do get actor location, and I'm going to plug this into the origin. So if my character is this shopkeeper, it's going to draw a big circle around this shopkeeper and it'll say find the random point in this radius. but only if it's reachable. So how does it define if something is reachable? And that's using the Navmesh. So if you press the P key, you will see that you'll have your Navmesh components up here, and your scene should be blue or green, depending on your Navmesh. As you can see, mine isn't. So how do we add Navmeshes to the system? It's super simple. All we're going to come and do is add a navigation bounds volume into the world. There we go. So if I drag this cube down, just like any other collider, you will see when it hits a floor or a collider, it will add the green outline, and that is now a Navmesh, that little section. So what I'm going to do is press Alt J to move to top view and zoom out of it, and now I can just stretch this out and fill it in where I need to. So you'll see it's clipping off here, and why is it doing that? So if we come down here, you can see that my cube is going to here, and thanks to the way with Unreal's agents are set up, it's saying you can get up a slope of this angle. I think it's like 45 degrees or something, maybe a bit more, but you can't get up here anymore because it's too steep. So how do we do that? Well, the first thing is we can just expand it a little and see if Unreal likes it. Okay, good. So it can reach it like so. So we can just position it, and you can see he can now walk all the way up there. And then we can come and expand it out like so, and you'll see it'll now allow him to walk all the way down here. Anywhere green is where this NPC can walk. You can see at the moment he can walk on top of here, but he won't be able to get up there, so that's fine for me. He can walk up here. He can-ish get up them stairs. That's something we'll look at eventually. That's just a collision issue. And then if he was in here, he can just walk a little bit here. So if you've got a very, very large game, it's not often considered best practice to add giant nav meshes like this. So eventually we'll look into making it more efficient. But for now, I'm just going to drag a really big nav mesh across my little village here. So you can see my village currently isn't using the nav mesh. So all I'm going to do just again is expand the height of it. And then eventually it will hit the floor. There you go. So I don't want my NPC to be able to walk onto this rock here. I think that's a bit weird. I'm just going to click it, come in and search for nav mesh, and you'll see can affect navigation. I'm just going to untick it. There we go. So now the NPC can't walk on top of there, which is what we want. I can also do the same for here. I could go in and just basically set it for all rocks, really. So you can see Unreal's clever nav mesh has already put a limit on where it can go. So it's locked all of these barrels off because they are blocking navigation. And you can see if I walk down here, they can successfully get a good chunk around this city here. And it gets them all the way over to here nearly. So I think that's good enough just for now. They will eventually be able to get up to the stairs when I fix my collisions, my collider issues, but they can also walk across the pond if they want. And I think that's good enough for me just for now. So I'm going to press P to hide it again, and I'll save it. Now you will notice if I drag another box in, like say this one, and duplicate it, it will rebuild the navigation like that. You can disable that in the properties if your game gets too big. Otherwise, I'm just going to keep as is for now. So now that we have our nav mesh installed, we can see that a random reachable point within the radius here, it's not going to come onto the water because it's not got the nav mesh on, but it will successfully walk all the way around here. Sometimes you will get random glitches like this where it says it can go on top of this roof at that specific point, and I'm not gonna lie, I've kind of butchered my houses at the moment. I tried to combine all the meshes so it's a lot easier, but it's messed it up. But what you would do is just tell the roof it can't be affected by nav mesh. You'll see though, if I come and tick the entire house to be not affected by the nav mesh, Unreal will just think you can walk through it straight away, and that's where you get NPCs who walk into walls and don't know what to do. So just make sure it's ticked as a nav mesh if it needs to be. So jumping back into our move to random location task, we now have a random reachable point. We need to give it a radius, so how large of an area can they look? I don't actually mind too much. I don't want them straying out far away, so I'm just going to set it to something like 2,000. So 2,000 Unreal units from, say, this shopkeeper around his point will give us a nice little radius. If you set it too much, say 10,000, they'll be trying to get to a point all the way over here. It's not realistic. It'll lag a lot. Just set it to something small. Don't set it too small. For example, when we set the smart objects up, we very well may want him to reach this house here to deliver something. If it's too small, he won't be able to find. So it's a nice little balance. Now that we've done that, we can plug the random location into the goal location. You can equally just do an actor if you want to. The acceptable radius is how close does this actor need to get to it. If I just quickly add a target point in like so, how close does this NPC have to get to this target actor here? Now if you've got multiple NPCs both trying to reach this target, they won't get it because you can see colliders will just hit each other and stop them. So you need to balance it so it's not too far away that it doesn't make sense, but it's enough where if they get to it, it'll complete the task off. So for me, I'm just going to set it to something like 200 Unreal units away. We'll get nice and close to it. You can see my axis going up. He'll get nice and close to it, but not too far away where it'll look a bit silly. If your target is moving, say the doctor is finding a plague victim or something like that, you can also tick continuous goal tracking. So instead of move to actor or location saying go to this vector, it will check continuously where that vector is. In my case, I want them to just reach a random spot. I don't need that on. It'll add more performance for it, so I'm going to keep that one off. If you had somebody following it, like a policeman or a guard following your character, then keep continuous tracking on. Or if you had an AI helper following you, make sure that's on. And now that we've done that, we can move on to the after part. So if request has failed, what do we want it to do? So we want to tell the task that you have failed, you can't get to this. This is, you can't reach it, you've died, somebody stopped you, something like that. So I'm going to drag off and I'm simply going to do finish task. And I'm going to make sure succeeded is crossed off. And then I will duplicate this, plug it into on move finished and click succeeded. You may not use these, you very well may actually use them. And then the top one here is what you want to do as soon as this has been told to run. So it will carry on doing it. We don't want to finish task on that one, otherwise that is, like I said earlier, where they'll keep trying to jump to different locations but they can't get it because it's continuously running. So with this task here, it will essentially freeze the state tree and wait for them to reach this location, which is exactly what we want. So let's go and apply this task to our state tree. So I'm going to come and click my walk to random location. I'm going to click the tasks on the plus and I'm going to search for it. So we've got a couple of tasks built in. Delay is to tell it to wait for a little bit. We'll probably use that one more often later. Debug text task adds some debug onto the HUD that the player owns. So if you want to view some stats or something, but we're just going to use our move to random location. Now it does say STT at the front. That's not fantastic. Let's go and change that. I'm going to go back to our task, click class settings, and you'll see we've got blueprint display name. I'm going to call it move to random location and hit compile and save. And now when we go back in to the task, you will see it says move to random location. It just looks a little nicer. And I'm going to click this one and I'm going to open it up. So as you can see, we already have one in variable, which is what we set earlier as the input. So that's why it's working. So you see it's asking us for it to provide one from the state tree. So I'm going to come and select the actor like so. That'll select our context actor, which is the character who's driving this. And there we go. So if we compile and save, and we can, now if we go back to our NPC, so I say I want this NPC here to do it. So I'm going to give him a different skin. So there we go. I've set up this random NPC here. She's in a nice little blue gown and I want her to walk around, which is perfect. I'm going to come and click on this NPC and I'm going to press Control B to find her and I'm going to open up my character. So we need to find where the AI controller is so we can use the state tree. So I'm going to search in the details in the class defaults for controller and you will see exactly which AI controller it uses. So currently it's using the ALS controller AI for me. You may not have one. If you don't, right click blueprint class, just create a AI controller and then set it on your character. I'm going to open mine up and take a look at it and you'll see this specific AI controller likes to have behavior trees added and stuff like that. I'm going to ignore that for now. So when I open up the AI controller that comes with ALS, you'll see that it's automatically expecting a behavior tree because that's just what ALS was built on when it was created. But I don't want to use that because I have a state tree logic I want and I don't want all NPCs to be using the state. I only want a few NPCs. So what I'm going to do is I'm going to actually duplicate this AI controller. I'm going to do copy. I'm going to add on the end of this underscore state tree. And this can be our state tree version. Now I could go into the C++ and just remove the bits I don't want, but now I'm not going to do that. All I'm going to do is click open for blueprint editor and I'm going to come and add a state tree to the top here. Now it'll ask us to pick a state tree. So I'm going to come in and select our random roam state tree and I'm going to make sure start logic automatically is ticked. So it'll start running it as soon as the game starts. So you'll see when I open my ALS AI controller, it's automatically got behavior trees built in mine, but I don't want AI to use that. I wanted to use the state tree. Now, if you haven't got the ALS AI controller and you've just got your own AI controller, you won't have a problem with this, but that's fine. I don't want all of my AIs using the state tree. I only want specific NPCs to be able to roam around. And eventually I'll have a master state tree where it'll call all the different state trees and it'll assign jobs to people. So the shopkeeper's job will be to stand there. If you shoot near him, he might attack you, he might run away. But for now, we just want to get the NPC moving. So all I'm going to do is come and make a copy of this ALS controller AI blueprint, and I'm going to call it underscore random roam. If you don't have an AI controller, simply right click blueprint class and create an AI controller. So inside here, I'm going to open it up and I'm going to delete the event begin play off and I'm going to add in a state tree component like so. I'm going to make sure that I select my state tree from the side and make sure start logic automatically is ticked. If it's unticked, it won't run the state tree. Then for some reason, I don't know if the state tree is bugged at the moment, but start logic automatically doesn't actually start the state tree automatically. You do have to add an event begin play and then simply drag the state tree and just call start logic. This very well may be fixed in Unreal 5.4. I'm currently using 5.3 and I'm going to hit compile and save. I'm going to find my ALS NPC. I'm going to make a child blueprint of it. And I'm going to call it ALS NPC underscore random roam. I'm going to drag this one out and I'm just going to replace the meshes over. There we go. But the difference is with this new NPC, I'm going to open it up and in the class defaults, I'm going to search for controller. I'm going to make sure it's using my new controller, random roam. I'm going to hit compile and save. And now with that, we should be able to start the game and the NPC should start randomly walking around. You can see she is now running to a random location. Where's she going? She's going down into the grass for some reason. Now she's stopping and turning around and moving to another location. There we go. She's moved to another one. And that is our NPC randomly roaming. It looks a bit odd at the moment because obviously we need to stop them running and, you know, make them actually do something. So let's tell them once they arrive at a location, just wait there for a little bit. Just a random duration, just to add to the point where they've actually reached their destination. So let's go back to our state tree and I'm going to right click this one here and I'm going to add a sibling state like so. And I'll add another state just under it. So I'm going to name this one to random wait and I'm going to add a delay pass. I'm going to open it up and I'm going to add a duration of say 3 and I'll add a random range of say 3. So it'll either wait there for 3 seconds or it'll take it on or off around that location to make it go. But you will notice that we now have a missing transition. So let's add a transition and tell it on completed go back to root. But we need to tell this random one to go to the next state. So I'm going to simply open this one up and I'm going to go transition to next state. So it'll basically go down to the next state it needs to go to. And now I can hit compile and save. And with that small change, the NPC should now walk to a random location, wait, and then move to a different location. And they'll wait randomly each time they arrive. But it'll look a little bit nicer. You can see she'll walk and she'll just wait there. You can play an idle animation if you want, make them look around, and now they'll just walk somewhere else. There you go. And now she's officially going places. So what I'm going to do is I'm just going to open my blueprint for this NPC, and because we're using ALS in this case, I just need to set their default speed, which is called a desired gait, and I'm going to set it to normal, to walking. If you're not using ALS and your character's running, chances are you just need to click your character movement component and set the max walk speed to something smaller. And now if we try again, you'll now see that the NPC is walking to their destination. It looks a lot more realistic for them to walk there, like so. There we go. So if you had a bunch of these NPCs walking around, as you can imagine, it would work quite nicely. So that's the basic state tree, ladies and gentlemen. A super basic thing we've added in at the moment to add a bunch of NPCs. They'll now randomly walk around, and in the future we can start plugging more things in, so we can set up state trees to make AI attack you if you've done something wrong, make it so they can follow you if you've got a companion or you're being asked to follow, and then eventually we will plug them in to actually use smart objects so they can go and actually interact in the world. So we could make this NPC walk up to this shopkeeper, pretend to have a conversation, maybe even gather some items for the inventory and walk away. So that will also lead on that we can do specific missions such as stealing from the NPC and stuff like that. So thank you for watching, ladies and gentlemen. I hope this was useful. If you run into any issues, please let me know below. My name is Decryption and I will see you next time.